Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Akil bin Zabani. My student ID is 2019-268616. Today we will be presenting about our lab 9, which is film-wise and job-wise conversation.
Hi, Assalamualaikum. My name is Nur Anissa Shafika binti Abdul Ghani from Eh2203H. My metric number is 2019628164.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nurdina binti Muhammad Faisal. I am from EH2203H and my metric number is 2019405388.
Hi, my name is Nur Aina Zira binti Ismail. My student ID 2019229918.
There are three objectives of this experiment. The first one is to demonstrate the film-wise and drop-wise condensation. The second one is to investigate the effect of different surface materials on the rate of condensation. And the third one is to relate the process of condensation with the thermodynamics. As we know, condensation is a process where the physical state of matter changes from gaseous phase into liquid phase. The droplets are formed when water vapor contacts with cooled surface. In addition, any gases condense in condition of high pressure and low temperature. The process of condensation is occurred naturally, and we can see the application of film-wise and drop-wise condensation in our daily life. For instance, moisture beads on car windows, sweaty drinking glass, fogging a mirror, and droplets on grass in the early morning. Basically, there are two types of condensation. The first one is a film-wise condensation, and the second one is a drop-wise condensation. As we can see from this figure, for film-wise condensation, there is a liquid film which is flowing down the cold wall, while for the drop-wise condensation, there are liquid droplets that are formed on the cooled wall. Drop-wise condensation occurs when the droplets of liquid are formed on the surface. It is known as one of the most effective in mechanism of heat transfer. Therefore, the extreme large of heat transfer coefficient can be achieved due to its mechanism. The heat transfer coefficient usually is 5 to 10 times greater than film-wise. Drop-wise condensation did not last long, and after some time, it will be converted into film-wise condensation.
In film-wise condensation, the condensate happens on a wetted surface and can be seen as a layer of film on the surface. The thickness of the film increases as the vapor condenses. The heat transfer on the surface is low because the formation of film layer delays the process. The condensate film layer covers the surface, therefore resulting in a high resistance towards heat transfer. As the film becomes thicker, it will cause the liquid to flow down the surface. This is depending on a few factors such as the height of the condensing surface, condensation rate, and the vapor velocity. Few notable differences between film-wise and drop-wise condensation are that drop-wise occurs on non-wettable surface, while film-wise occurs on wettable surface. Other than that, drop-wise condensation happens when the surface is directly exposed to the vapor. Lastly, the heat transfer in drop-wise condensation is roughly 10 times larger than film-wise condensation. The condensation process that occurs also depends on the type of surface that the condensate will accumulate. It may depend on how well the surface conduct heat. This is because when vapor becomes in contact with a surface that is a heat conductor, the temperature of the vapor will easily change because of the conduction that happens. It is harder to see condensation happens in non-heat conductor surface as the heat transfer process takes more time.
So in this film and dropwise condensation experiment, we chose to study and perform the dropwise condensation experiment. This experiment is carried out by using cold water that is filled in two different types of cup, which is glass cup and the plastic cup, which is also then filled with ice. The rate of condensation on both type of cup is observed. So starting from 0 minute, the temperature of surface of water, the surface of cup, and the temperature of surrounding is taken every 5 minutes until the 15th minute. So after we carried out the experiment, we gather all the data of every trial of each plastic cup and glass cup, and we calculate the average reading of temperature. So based on the average reading of temperature, two graphs are plotted, which is temperature versus time using plastic cup and also using glass cup. So as we can see on both graphs, the temperature of surrounding for plastic cup and glass cup are maintained at 25 degrees Celsius and 30 degrees Celsius. As for the temperature of water inside the glass cup, it increases linearly from 6 degrees to 17.3, but then it dropped to 16.6 degrees Celsius. As for the cup's surface, it dropped from 21.06 degrees Celsius to 16.1, but then is maintained at 16.5 until the end of experiment. As for the plastic cup, the temperature of the cup's surface decreases gradually from 14.7 degrees Celsius to 11.2 at the end of the experiment, while the temperature of water inside the cup also decreases gradually from 7.7 to 5.6, but from 10 to 15th minute, it has a slight increase to 6.7 degrees Celsius. Therefore, we can see that the temperature of water inside glass cup and also the temperature of the glass cup surface increases faster than the plastic cup. The increasing of temperature is higher in glass than in plastic because, as we can see here, the thermal conductivity of plastic is lower than the glass. Therefore, the heat transfer is faster in glass compared to in plastic. Next, condensation occurs more in glass cup compared to in plastic cup. So let's look at one example over here. When a warm air comes into contact with cold material that conducts heat, like glass, the water vapor in the warm air will lose heat because the heat is transferred into the glass by conduction. So when it loses heat, the water molecules will start to coalesce and stick together, which forms the water droplets or the condensation. The plastic does not conduct heat as well as glass, so the condensation less occurs in plastic cup. Dropwise condensation is more preferred compared to the film-wise condensation as the heat coefficient of dropwise condensation is higher. This is also the reason why dropwise condensation is favored and is regularly used in engineering field. So the example of the application of dropwise condensation in the engineering field is petrochemical refining, desalination, power plant, electronic thermal management, water harvesting, HVAC&R.
In conclusion, the experiment has been demonstrated to observe the characteristic for the both film-wise and dropwise condensation. The average temperature of the plastic cup and glass cup in water inside cup surface and surrounding are 60.6 degrees Celsius, 60.5 and 29.3, while in the plastic cup are 6.7 degrees Celsius, 11.2 and 25.5. Hence, the glass cup is have highest volume of heat transfer than plastic cup. In order to relate the condensation process with the thermodynamic theory, it can be said that the condensation process apply the first law of thermodynamic theory, which energy cannot be created nor destroyed. It can only change from one form to another. The condensation occurs when the heat from water vapor released due to contact with the lower surface of temperature and forms water in liquid phase. The objective of this experiment are achieved.